Hello everyone. Today we will present to you about our research paper entitled Audio-Based Indonesia Toxic Language Classification Using Bidirectional Long Short-Term Memory. In the research group, there is me, Renaldi Addison, Marvin Luckianto, and Vincent. Today's discussion will be separated into four parts: problem and abstract, literature review, system design methodology, and the last part will be evaluation. So the first part will be problem and abstract. Social media platforms enable users to communicate through web-based technology. However, it has become a platform where hate speech spread easily. Hate speech and cybercrime, including defamation, make up to significant portion, up to 80% of incidents investigated by Directorate of Criminal Acts Cyber Barreskrim. Despite existing laws in Indonesia, such as UITE Law, Chapter 28, Number 2, which prohibits inciting hatred based on race, religion, or ethnicity, hate speech remains prevalent. The Indonesian government itself has taken steps to combat this issue. However, more steps will be need to be done to address and reduce the impact of hate speech in the nation. There is no standard definition of toxic behavior. Generally, we define it as behavior that intentionally disturb other people's convenience. Some examples are cyberbullying, cyber threats, online harassment, hate speech, and abuse. The second part will be literature review. In the recent years, the issue of hate speech on social media platforms has become a crucial problem, prompting several studies to address this issue. One such study is Same Evil 2019 Task 5, which aims to detect hate speech against immigrants and women in Spanish and English messages from Twitter using the support vector machine (SVM) method. Additionally, a 2022 study on Indonesia hate speech detection achieved a high overall accuracy, precision, and recall of 97.66%, 96.50%, and 85.25% respectively, using the Twitter dataset. In conclusion, the using of machine learning and deep learning techniques has shown promising results in identifying and classifying toxic language in speech in various forms, including cyberbullying, hate speech, and offensive comments. These studies reviewed demonstrate the effectiveness of various algorithms and architectures such as CNNs, LSTMs, random forests, and BERT in achieving high accuracy and F1 score.
Next, in the methodology of this research, we conducted several experiments, including the first one is on the dataset. We successfully gathered a dataset comprising 5,000 instances divided into two classes. They are toxic and non-toxic. We then pre-process the data and perform data labeling to ensure that the data can be processed by the proposed model. We then applied several machine learning and deep learning algorithms to compare the proposed model with models previously used in other studies. The models used for comparison including naive Bayes, random forest, and self-attentive CNN. The model we propose used bidirectional long short-term memory or BILSTM, as BILSTM can capture the information contained both in the previous and subsequent sequence. In the case of natural language processing, BILSTM can help in better context understanding as it can take into account the context before and after each word or token. Next, we divided the dataset into three parts. They are training, validation, and testing sets with a ratio of 80, 10, and 10. Finally, the neural network model construct consists of several layers. There is a factorization layer, an embedding layer, two bidirectional LSTM layers, one dense layer with dropout, and lastly a dense layer.
In this study, we use a dataset that comes from different sources such as Nusakro, Kaggle, and other websites. We made sure that each category had a similar number of samples, which helped us achieve a balanced and meaningful distribution of data. Overall, we had a total 5,000 datasets divided into two categories, toxic and non-toxic. To prepare the dataset, we remove all emoji, symbol, and focusly on plain text and pronunciation. In the evaluation, the provide research detail include the result of training a model for a specific task. The model was run for 15 epochs, with each epoch consisting of several steps or bits. The training process involved measuring the loss and accuracy on board the training data and separate validation dataset. And next, in this specific case, the model achieved 256 true positive, indicating the correct identification of instance as positive. It also have 8 false positive, 16 false negative, 220 true negative, correctly identifying instance as negative. By utilizing the receiver operating characteristic curve of a comprehensive assessment in Provide, the confusion metric revealed the 10 insight into model performance, including true positive, false negative, and true negative, enabling a deeper understanding of specific error types. And next in the table, the accuracy, precision, recall, and F1 score metric for the different models on the dataset. The specific model mentioned is the BLSTM achieved an accuracy of 95.2%, indicating that it correctly classified 95.2% of instances in the dataset. The precision of the model, which measured the proposition of correctly predict positive instead of all instance predicted as positive, is 96.4%. This indicates that when the model predicted an instance as positive. In this study, we propose an advanced model called Recurrent Neural Network, RNN, with bidirectional long short-term memory (BLSTM) architecture for decoding toxic speech Indonesia audio data, achieving 95.2 accuracy, 96.4% precision, and 93.2 recall in the toxic language classification. Direction will pave the way for more comprehensive and effective approach in monitoring and mitigating toxic language across various audio-based applications. Thank you for watching our presentation.